graphing calculator to graph each pair of equations. So we're going to graph the first pair of equations on our graphing calculator. So what you do is go to your home screen, click y equals. If there's anything typed in there, clear it out. And then x is right here below the word mode. So you're going to hit x plus 5. Go down to y2 and type in negative 2x plus 5. And then you're going to click zoom and the number 6, which stands for zoom standard. So again, enter your equations in y1 and y2. And we're looking at example A right now. And it says use a graphing calculator to graph each pair. So when I graph these two equations, what do we notice about those two equations? They what? They intersect, right? They cross each other. So question 2 says, do the graphs have any points in common? If so, how many? So the answer would be yes, 1. Okay. And then let's look at the graphs in example B. So go back to y equals, retype in your equations, so clear out what's there, and type in 3x plus 2 as well as 3x minus 1. And once you've typed in both of those, you can hit the word graph. And what do you notice about your equations this time? What do you notice this time? They are what? They're parallel. So the graphs of the equations in this example are parallel. So do these graphs have anything in common? Do they intersect at all? No, they're parallel. So parallel lines do not intersect. So for part 2, where it says, do the graphs have any points in common? The answer is no, none. Okay, going back to that graphing calculator. For this part, I'm going to teach you kind of how to type fractions on your calculators today. So clear out equation 1, put in that negative 4x minus 2. And then if you're using my graphing calculators, you have to be careful about how you type in the equation for part 2. So you got to put a parenthesis around everything in the numerator. So you're going to put that 8x plus 4 in a parenthesis and then divide it by negative 2. Division. And then hit graph. And what do you notice about the graph this time? They're on top of each other. Fantastic. So, if they're on top of each other, do they have any points in common? All of them. All right, so let's pick up with our notes packet. Hi guys. That's what happens when I stop sharing my screen. All right. I almost just wrote on my iPad with a pen. Alright, so how many points do they have in common? We said yes, they had 1, B had none, and C had all. For part A, it says compare the slopes of the graphs. What is the relationship between the slopes and the number of points in common? So in part A, our slopes are different. So they had 1 point in common. For part B, the slopes were the same and they had no points in common. In part C, the slopes were the same and they had all points in common. So that should tell me something about this lesson. It should tell me that slope is going to be very important. That tells you something about this lesson, and that is that slope is very important. So let's construct a table creating a relationship between those 3 graphs and slope as well as y-intercept. So example A represented intersecting lines. Intersecting lines have 1 point of intersection. In order to intersect only once, they have to have different slopes. In order to intersect only once, they have to have different slopes. They can have the same y-intercept though. They don't have to, but they can. Example B represented parallel lines. Parallel lines have no points of intersection. Their slopes have to be the same, and their y-intercepts must be different. Their slopes have to be the same, and their y-intercepts must be different. Part C, you had coinciding lines. And for coinciding lines, they have infinitely many points in common, and their slopes have to be the same as well as their y-intercepts. Okay? So we're going to look at some new vocabulary today. We have a system of equations. That is a set of 2 or more equations that use the same variables. A linear system, that is a system of equations that will have lines for their graphs. The solution to a system of equations is the intersection of their graphs. So last week and earlier this week, when we were solving systems of equations by substitution or elimination, that answer that you got told me that those were intersecting lines. That answer that you got told me that those were intersecting lines. An independent system is a system that has one solution. An independent system is a system that has one solution. A dependent system has many, and an inconsistent system has none. Bless you. All right. So here is a graphical example relating all of the vocabulary words that we just discussed. So each type of system solution set will have 3 descriptions or classifications. Intersecting lines are classified as one solution and independent systems. So if you have intersecting lines, you also say they have one solution, and that is an independent system. Coinciding lines have infinitely many solutions, and we call that a dependent system. So if you think back to the other day, we had the case where we had 0 equals 0. That represented coinciding lines. When we got 0 equals 0 with substitution or elimination, that represented coinciding lines. When we got 0 equal to a number, that was representative of parallel lines. When we had 0 equals a number, that was representative of parallel lines, because parallel lines have no solution. Parallel lines have no solution and give an inconsistent system. So you guys filled in your boxes? So without graphing these or solving these like we did last week, we're going to classify them. So without graphing or solving, we're going to classify. So in order to classify, we need to do 2 things. We need to rewrite both equations in y equals mx plus b form. So in order to classify, we're going to rewrite both equations in y equals mx plus b form. So in this case, equation 1 is done. That's in y equals mx plus b form. So we're going to have to do that for equation 2 though. So what we're going to do is solve for y in equation 2. So you have negative 6x plus 2y equals 4. So you're going to add 6x to both sides and divide by 2. So when I simplify equation 2, I get y equals 3x plus 2. If I compare the slopes of both those equations, the slopes are the same. If I compare the y-intercepts, they're also the same. So if 2 equations have the same slope and the same y-intercept, then these are coinciding lines with infinitely many solutions. And we classify that as a dependent system. So in order to classify a system without graphing, you need 3 answers. You got to describe the lines, describe the solutions, and tell me what type of system it is. Number 2, we're going to solve both of those for y. So I get y equals negative 3x plus 5. And then down below we subtract 15x from both sides. So you get 5y equals negative 15x plus 2. Divide both sides by 5. And this time, when I compare key pieces of information, the slopes are the same, but the y-intercepts are different. So same slope, but different y-intercepts tell me that I have parallel lines. You're going to actually know how to spell that word by the end of this unit. Parallel lines have no solution. And we classify the system as inconsistent. Number 3. Equation 1 is already solved for y. So we have to solve equation 2. So we add 4x to both sides. Divide by 2. And once again, I notice that the slope and the y-intercepts are the same. So same slope, same y-intercept gives me a set of coinciding lines. That have infinitely many solutions and represent a dependent system. Solving for y in example 4. We subtract x from both sides. But that leaves a negative y, so you have to also divide by negative 1. So I get y equals x minus 5. Boys, if we can't wear our masks, I am going to write you up. This is like the 99th day of school. Figure it out. Or enjoy detention. I'm tired of yelling. Okay, and then subtract 3 from the other equation. And we get y equals 2x minus 3. So we have different slopes. So different slopes tells me I have intersecting lines, which tells me I have one solution. And these are independent. So I always like to remember intersecting goes with independent. Intersecting goes with independent. Okay, your assignment is to complete the next page in that packet, classifying the lines both based on graphs and equations. So you're classifying the lines based on graphs and equations.